Hey, what's up guys? So we are in 7.4, and if you remember from 7.2, in 7.2 we talked about parallelograms, and if we do just a quick review of that, we learned that parallelograms are quadrilaterals that have two pairs of parallel lines, and opposite sides were parallel. So if you remember that from a parallelogram. We learned four different properties or theorems from parallelograms. First of all, if a quadrilateral is a parallelogram, then we know that the sides opposite are congruent and that the angles opposite are congruent. So sides and angles, opposite sides and angles were congruent. We also learned that consecutive angles were supplementary. So either that's the top two, the bottom two, the left two, the right two angles together were supplementary. And then we learned that the diagonals that they create, so from drawing from one vertex to the next, that they bisect each other, that the diagonals bisect, meaning that these two parts of the diagonal are congruent, and these two parts of the diagonal are also congruent. So this leads us into 7.4. We're skipping over 7.3, but for 7.4 we're going to learn about special parallelograms, some special types of parallelograms. So here we have three different types of parallelograms. So the first special parallelogram is a rhombus. So this right here is a rhombus. And a rhombus is a parallelogram with four congruent sides. So we learned that a parallelogram, no matter what parallelogram, any parallelogram has opposite sides that are congruent, but if all four sides are congruent, this is what we call a rhombus. Okay. Again, not every parallelogram means that all four sides are congruent, but when all four sides are congruent, this is considered a rhombus. And then over here we have the rectangle. So a rectangle is a parallelogram with four right triangles. Four right angles. Okay? So meaning that pretty much what this is saying is that all four angles are congruent, and the only way for all four angles of a parallelogram to be congruent is when they are right angles. So here's a right angle, here's a right angle, and right angle. So a rectangle is a parallelogram with four right angles. And then we come to the square, and a square is a parallelogram with four congruent sides and four right angles. So a square is both a rectangle and a rhombus at the same time, and a parallelogram. So it has to have four congruent sides, and all four angles have to be right angles. And this is how we have these three special rhombus parallelograms. So let's look at this example here. And in this example, it says for any rhombus, now remember when it says rhombus, we're thinking of all congruent sides. For any rhombus, QRST, excuse me, decide whether the statement is always or sometimes true, and draw a diagram that explains your reasoning. So for A, it says decide whether the statement is always true. So this statement says that angle Q and angle S are congruent. Now, for any rhombus, is this true? For any rhombus, is this true? By definition, a rhombus is a parallelogram. So I know that. So by definition, a rhombus is a parallelogram. And by the opposite angles theorem, of parallelograms, opposite angles are always congruent. Opposite angles are congruent. So that means for any rhombus, this is true. For any rhombus, Q and S will be congruent. So this will always be true. So this statement right here, Q is congruent to S, that's always going to be true. For any parallelogram, or for any rhombus, Q and S, opposite angles, will always be congruent. Now, let's look at B. So for B, angle Q and angle R are congruent. For any rhombus, well, let's take a look at these three rhombuses. So for these two rhombuses, for a square and a rectangle, these two angles will be congruent, but not for a rhombus. So this won't be true for a rhombus. Yeah, won't always be true. Won't always be true for a rhombus. Because again, we know that there are some rhombuses where these two angles will not be congruent, or in other words, they won't be right angles. So this is only true, I guess, for squares and rectangles. So this is only sometimes true. So sometimes true. Okay. Now let's come down here. In this example, it's saying to classify special quadrilaterals, so we want to classify this. So first of all, let's look at what we know about this diagram. We are given that we have this side and this side, this side and this side are all congruent. So all those sides are congruent. And so that must mean that this is a rhombus. This has to be a rhombus. And it doesn't say anything about the angles being congruent, because one of the angles is not a right angle. So right here it's 70 degrees. If it were 90 degrees, then we could classify this more specifically as a square, but we can't say that because it's 70 degrees. So we can just say that this is a rhombus. And we know that because all four sides are congruent. Alright, Now let's learn about some properties in theorems. So here, the rhombus diagonal theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So right here in this rhombus, in this rhombus, a rhombus will always have its diagonals perpendicular to each other. So not every parallelogram will have this, but every rhombus will have this. This will be true for any rhombus, okay? So for any rhombus, the diagonals are perpendicular. So if they're perpendicular, this means intersect with 90. This means intersect with 90 degrees. So you can see that here's the diagonal BD, and here's the diagonal AC, and they intersect at 90 degrees. So each angle inside here is 90 degrees. Okay, and not only that, but a parallelogram is a rhombus if and only if diagonals bisect a pair of opposite angles. So right over here, so in this a rhombus means that the diagonals will also bisect these angles. Every angle will be bisected by its respective diagonal. Okay, so the diagonal AC bisects angle A, meaning that this angle right here and this angle right here are congruent. And it also bisects this angle right here, meaning that this angle and this angle are congruent. And this diagonal BD bisects angle D and angle B. Now this doesn't work for every single parallelogram. So for example, if you guys remember in the extra practice right here, hopefully you guys were able to figure this out, but this was a parallelogram, and these sides right here are not congruent. So this means that it's not a rhombus. It's still a parallelogram because the opposite sides are parallel, but it's not a rhombus. And so this angle right here is not not congruent right here because it's not a rhombus, meaning that these diagonals do not bisect these angles. These angles are not bisected, and these angles right here are not bisected by this diagonal. Okay, and this angle right here is not 90 degrees. Okay, so just be careful of that. Okay, so now that we know that, these two theorems, find the measures of the number angles in the rhombus. Okay, so first of all, we know that this angle right here, this angle right here is 61 degrees. And I also know that this angle right here is 61. I guess before we get to that, but what we do know is that we have these diagonals, right? So here's a diagonal and here's a diagonal, and it also said that this is a rhombus. So if this is a rhombus, that means these sides are all congruent. All these sides are congruent with each other. That also means from this rhombus diagonals theorem, these angles created from the intersecting diagonals are 90 degrees. So that means angle 1. So measure of angle 1 has to equal 90 degrees. So that one's kind of an easy one. Now let's go to angle 2. So for angle 2 is alternate interior angle with this angle right here. So angle 2 has to equal 61 degrees. So let's make sure that we're listing the theorem. So this is because of the rhombus diagonals theorem. This one is from alternate interior angles. Measure of angle 3. Now, since this is a rhombus, the diagonals bisect these angles. So if they're bisected, that means angle 2 and angle 3 are congruent. So angle 3 is also 61 degrees, and we know that from the rhombus opposite angles theorem. Yeah, opposite angles theorem. Okay. Now we need to find angle 4. Here's the thing about angle 4 is that we already know that this is a triangle right here, and we already know angle 1 and 3. So the sum of 1, 3, and 4 have to equal 180 degrees. So measure of angle 1 plus measure of angle 3 plus measure of angle 4 has to equal 180 degrees, and that's by the triangle sum theorem. So measure of angle 1 is 90, measure of angle 3 is 61, and measure of angle 4 is what we're trying to find. This is equal to 180 degrees. So I can subtract 90 and subtract 61. So subtract 90, subtract 61. And then here, these are 0. This becomes measure of angle 4 is equal to, and then, well, 180 minus 90 is just going to be 90, right? So 180 minus 90 is 90, and then minus 61 from that, and that's going to be 29 degrees. So measure of angle 4 is 29 degrees. So there we go. We have all those measures figured out and solved for. Alright. Now let's come talk about this this last theorem here. So this is the rectangle diagonals theorem. A parallelogram is a rectangle if and only if its diagonals are congruent. A parallelogram is a rectangle if and only if the diagonals are congruent. So here are the diagonals. Here's a diagonal. Here's a diagonal. So if the diagonals are the same, then that means you have a rectangle. So if AC is equal to AB, then this is a rectangle. Okay. So in example 5, it says in rectangle QRST, QS. So this one right here is equal to 5x minus 31, and RT is equal to 2x plus 11. Find the lengths of the diagonals of QRST. So find the lengths of these diagonals. Well, since we know that this is a rectangle, then we know by this theorem that the diagonals are congruent. So if the diagonals are congruent, I can take 2x plus 11 and set it equal to 5x minus 31. Here I can solve for x. So I'm going to get x's to the left side. So I'm going to subtract 2x from over here, subtract 2x over there. So 2x minus 2x is 0. Drop down the 11 equals 5x minus 2x is 3x minus 31. Now I want to get 31 on the other side, so I'll add 31 to both sides. So negative 31 plus 31 is 0. And I still have the 3x over here. And then 11 plus 31, that's going to equal 42. I can divide by 3. So then I get x is equal to 14. Now, I didn't want to find the value of the variable. That's not what we're looking for. We want to find the lengths of the diagonals. So let me take 2x plus 11 and put in the x value. So then this becomes 2 times 14 plus 11. So that should be equal to 28 plus 11. And that's going to equal 39. So there's one side length of diagonal. And here's the thing, because the diagonals are equivalent to each other, I could also, when I plug it into 5x minus 31, when I plug in 14 here, so 5 times 14 minus 31, this is going to equal 39. Now you can verify that, no problem, but we know that the diagonals are equivalent to each other, so that means the side lengths are going to be 39. So QS, which is equivalent to RT, is going to equal 39. Okay. Now that should pretty much do it for us in this lesson today, and that should finish off 7.4. Next lesson up ahead is 7.5.